All right. So welcome to our regular occurring webinar series. We've had a few this week, and I know that we just had one on Douglas Point as well. So we're hopeful that this will be just as informative, and we'll have lots of questions at the end. Today's webinar is on our future CRL, Chalk River Laboratories, future waste management capabilities. And we've got a great set of staff on the line today to run us through a presentation in the Q&A session. So really looking forward to that. And of course, they'll introduce themselves as we run through that presentation. But first, I'd like to introduce myself. I'll be facilitating this call today. My name's Mitch McKay. I'm the manager of stakeholder relations for the Environmental Remediation Management Communications team here at Canadian Nuclear Laboratories. And we're most of the team is based out of here at Chalk River, but we also have staff at our various other remediation sites across Canada. So a little bit about some of the webinar, how it's going to work today. We're going to obviously do this through the Zoom platform here. And I want you to make you aware that this is available in both French and English. The way you can toggle that is there is a button at the bottom of your Zoom platform there. It looks like a little globe, and it's called interpretation. So you can toggle between French and English. For the question and answer period, there's also a bottom at the bottom of the page, there's a Q&A button. And if you have any questions, you can enter those into the Q&A. Obviously, we're staying within the scope of the presentation today. So that's having to do with the waste management capabilities at Chalk River Laboratories. So if you want questions related to the scope of the presentation today, certainly we have the right people online to answer those. If we get questions that are out of scope, we will commit to answer them, but we'll have to answer them at a later time in writing. This particular webinar as well, at the end, we'll have a few poll questions, so please stay on for that and help us obviously make the webinars better, but as well answer a few questions about how to move forward with some of our waste management capabilities. And if there is any additional questions that you come up with afterwards that you're thinking about, or if there's some additional information needs, you can always get a hold of us at that email address there on the screen, ermstakeholder@cnl.ca, and we'd be happy to work with you on helping you find more information or answer additional questions. And as always, we have a large bank of webinars available on our YouTube channel. We've been doing these bi-monthly webinars now for several years. So there's a big it's a big resource if you want to take a deep dive on what CNL's doing and what's happening at a various site. It's a great resource. You can go back and look at many of our different webinars and listen to many of our different technical experts. And again, you know, if you come up with different questions there, we're here to answer. So with that, I think I'm going to hand it over to the team to run us through Chalk River Laboratories' future waste management capabilities. So am I starting with Caitlin or Kyle?
Not yet, Mitch. You've got a couple more to run through.
Oh, okay. All right, well, next slide then. Oh, okay. So CNL's mission to restore and protect. So Maybe some people on the webinar are aware, uh, uh, Canadian Nuclear Laboratories has several missions, and one of those missions is to restore and protect. And that's restore and protect the environment by managing the legacy liabilities that are at our sites across Canada. And in order to fulfill that mission, we've got a plan, and we've got to look ahead and think about, you know, the different waste streams, the different legacy facilities on our various sites, and find out how and where and what we will do with those various streams. And so today we're going to talk a little bit about, you know, those enabling capabilities that we may need moving into the future to help us manage these liabilities. And that's ultimately guided by CNL's integrated waste strategy, um, which provides the framework for how we will manage these liabilities. And so as part of that integrated waste strategy, we look at the enabling facilities that will manage kind of through the life cycle of the various waste streams that come out of the cleanup of our sites across Canada. So why we're here today talking about this is because, of course, they're just enabling. They're enabling capabilities that we we want to ensure that both our public and our Indigenous communities start to learn about some of the problems that we have to tackle moving into the future to properly manage these different streams. And of course, early engagement on some of these problems and identifying some of the things that are important considerations from a public and Indigenous perspective is important to CNL in making sure that our mission to restore and protect Canada's environment takes into account those things that are important to the communities that surround our sites. So with that, I'll move to the next slide. I should also point out, I did notice on the last slide that we have done a webinar on the integrated waste strategy. So if people are interested in the integrated waste strategy, I believe it was a February webinar, you can go back and have a look at. So currently, waste storage at CNL site is just storage. So other than at the Port Hope site, where we have come up with a long-term facility for low-level waste, we are storing waste across our sites and managing it into the future. Obviously, you management of these into the future uh, is has a time cycle. So, you know, things only have a design life that lasts for a certain period of time, and we have to think about, okay, what are we going to do with some of these storage facilities as we move past design life or closer to end of design life. And so that's really what some of the questions around these enabling capabilities are trying to address. And so, as you can see, through the different sites have different. The middle site there at White Shell has storage bunkers, has the SMAGS facility, which is a shielded above ground storage facility. We have bunkers here at the Chalk River site, and then you may have heard of the high-level waste fuel packaging and storage facility at Chalk River as well. That's a newer facility that's taking some of those legacy tile holes and reconditioning and putting them into to modern storage. So those are some of the examples of how we currently store waste. So as I've been mentioning, to the enabling capabilities at Chalk River, we need to deliver on broad commitments for safe and efficient and effective waste management at CNL. And through this, we're identifying needs, right? So those enabling capabilities are really needs or problems that we need to solve, that we know we need moving into the future. And so, you know, for legacy waste like the retrieval, the conditioning, and the storage, and obviously some of the waste that we have can be retreated, like the treated heavy water management project, and then of course a cast facility, which is really a improvement on an activity that's already taking place outdoors, and moving it into a new facility that controls and conditions around the casts, and make sure that that those casts that move waste around our site are in good condition and can perform safely. Next slide. So legacy waste capability. So this is, am I turning this over to Kyle now?
I think that's the plan, right, Rachel? All right, thanks, Mitch. And good morning, everyone. My name is Kyle Chenor. I'm the manager of the Fuel Stabilization and Storage branch of the Fuel Program Division in Environmental Remediation here at CNL. I'm going to talk a bit today about the future waste management capabilities that CNL is investigating to address AECL's inventory of used nuclear fuel and co-stored intermediate level wastes, which have been produced over the long history of AECL and CNL's operating reactors here at Chalk River and at our offsites. While, as Mitch mentioned, all these materials are currently being safely and compliantly stored, managed, and monitored, these future capabilities are going to be required to bridge the gap between our current storage practices and eventual permanent disposal. And for used fuel, that disposal solution is relatively well defined, and it's the deep geological repository for all of Canada's used fuel, which the Nuclear Waste Management Organization is developing through their adaptive phase management project. And the graphic here on this slide shows a conceptual rendering of the DGR from NWMO's website. So if you're interested in anything related to NWMO or the APM project, that linked website is a great resource for more info there. NWMO is designing the DGR primarily for CANDU fuel, since CANDU fuel represents about 99% of the inventory in Canada. And while a large portion of AECL's inventory is prototype CANDU fuel from the nuclear power demonstration reactor, the Gentilly 1 reactor, and Douglas Point reactors. And it's quite similar in a lot of respects to commercial CANDU fuel. We do have an inventory of research reactor fuels from the NRU reactor, NRX, and WR1, which differ in many ways compared with typical CANDU fuel. So we're currently in the early planning phases of identifying and evaluating and developing these capabilities that we'll need in order to retrieve and condition the used fuel in a safe and efficient manner, and in a way that will be compliant with waste acceptance criteria for the DGR. And we're also defining requirements for storing conditioned waste. So after these wastes are retrieved and conditioned, we'll need capabilities to store those until the disposal facilities are operational. So as part of developing these capabilities, we're working closely with the NWMO to better define those waste acceptance criteria, specifically for our non-standard fuel inventory. We're also working with them to progress on research and development on technologies we've identified as potential solutions for meeting these waste acceptance criteria. And we're working with other national laboratories in the US and in Europe with similar challenges in order to validate the work we're doing and also learn from work they've done and are planning to do. The work we're doing is in establishing these capabilities is critical to ensuring that all of the used fuel wastes in our inventory have a clear path to permanent disposal, and we're not leaving orphaned waste forms without a defined and feasible path for permanent disposal. And it's also essential enabling work to allow for environmental remediation of the land in and around our existing waste management areas. The work we're doing on this is informed by and aligned with our broader strategic documents and policies like the integrated waste strategy, the overall decommissioning and cleanup plan, and Natural Resource Canada's recently revised policy for radioactive waste management and decommissioning. That's all I had. Thanks everyone for your time. I'm going to hang out for the Q&A period. So if you have any questions about any of this, please get them into the Q&A. Again, thanks for your time, and I'll pass it back to Mitch, I guess.
Sure thing. And I think I'm passing it over now for the tritiated heavy water management project.
That's right. That's me, Mitch.
Yeah, go ahead, Brandon.
Okay, great. So thanks, Mitch. Good morning, everyone. My name is Brendan Pilgrim, and I am the project leader for the Tritiated Heavy Water Management Project, and I'll be presenting a brief overview of that project to you today. So AECL owns an inventory of tritiated heavy water. And maybe for those of you that don't know, Canada reactors use heavy water as a moderator, and that water becomes tritiated as a result of that fission process. So this inventory was amassed from reactor operations. This inventory of heavy water is presently safely stored in certified packaging at the Canadian Nuclear Laboratories Laboratories, Quebec site and the CRL site here. The inventory has been defined by the Government of Canada as a liability that requires disposition. Detritiation was selected as the disposition route as it recycles this inventory for future use, and it minimizes this requirement for ongoing storage at these locations. The detritiation process will use combined electrolysis and catalytic exchange, so abbreviated to CECE, as the technology to remove the tritium from the majority of heavy water, while cryogenic distillation will be used as a technology to concentrate and remove the elemental tritium from the remaining product water. So this isn't new to CNL. We have significant design and operating experience previously with the detritiation of heavy water. And this has been proven with the successful operation of a pilot CECE facility that operated here on the CRL site from about 1998 to 2001, so a 3-year span there. CNL is proposing to construct a modernized CECE facility at the Chalk River Laboratories site. So once this facility is constructed, we're expecting operations to take about 7 years to process the entire inventory. So if I can just draw your attention for a sec to the right side of the screen, and the artistic renderings we have of the facility are there. So the upper picture kind of is an overview of the facility, and you can see a distinct tower section in the middle, and that's where the process columns will be located. The lower picture has kind of the cladding removed, so you can see a bit more of the inner workings, some of the facility structure, and some of the process equipment. The result of this process is two products. So this is what we're left with at the end of the day. We're left with the elemental tritium and detritiated heavy water. And both of these are considered assets, and they have value in the non-nuclear markets. So this is truly a win-win solution where a liability waste is being recycled into assets. In closing, this project supports CNL's primary mission to restore and protect Canada's environment and is a key initiative under the Environmental Remediation Management Mandate to accelerate the elimination of nuclear liabilities on behalf of Atomic Energy of Canada Limited. So I want to thank you for your time today, everyone. And like Kyle, I'll remain after for the Q&A session, and I appreciate your time today. Thank you. I guess back to you, Mitch.
Yeah, thanks, Brennan. And we'll go over to Caitlin now.
Good morning, everyone. My name is Caitlin McMillan, and I'm the project engineering representative supporting the design, construction, and commissioning of the cask facility at our Chalk River location. This facility will centralize CNL cask operations. A cask can be defined as an on-site transfer flask or an off-site transportation package. And cask operations can include loading, unloading, storage, and maintenance. I'll begin with a brief overview of the purpose of this facility. Chalk River Laboratories regularly ships, receives casks to and from offsite facilities. In support of consolidating our liabilities and ongoing and future science and technology missions, the frequency of these shipments are projected to substantially increase over the next 5 years. The cask facility is projected to send on and offsite shipments of intermediate level waste and high level waste. I'll also provide a few enabling capabilities of the facility to you this morning. The cask facility enables the consolidation of Atomic Energy of Canada's Limited used fuel and intermediate level waste liabilities. This facility will also support the Advanced Nuclear Materials Research Center, the ANMRC's operations. This facility also supports overall CNL cask maintenance. The cask facility provides increased efficiencies for shipment operations by having the right facilities, equipment, and resources to support the majority of our cask operations on site. The cask facility also demonstrates a continuously improved safety culture and commitment to excellence by having a fit-for-purpose facility with the right tools and resources for cask operations in a climate-controlled environment. So I also wanted to provide a brief update on the location of the facility. The location of this facility has been selected through our site selection process to be near the existing waste management areas. And an overall project update, the project was originally presented to the Environmental Stewardship Committee in June of 2021. Our detailed design of this facility is ongoing at the moment, and construction of the facility will commence once the detailed design phase is accepted. Like Kyle and Brennan, I'll be around for the Q&A session.
Awesome. Thank you, Caitlin. All right, next slide. We're getting into the polls, so we'll hand it over to Rachel to do these polls.
Thanks, Mitch. So we have a couple of questions for the folks participating today. So would you like more information on CNL's overall plans for the legacy waste capabilities? This is a single choice answer, and we'll give people a few moments to get their responses in before we move on to the next one. Participating in these polls today helps us plan future sessions for you folks on the call. Awesome. So we're kind of, that was a quick response one. So yes, people are very interested in learning more about this. So that's fantastic. So we're going to move on to the next poll here. We wanted to know about the level of information that we presented today. So did the presentation have the right level of detail for you to understand the material covered? So presentation had the right level, it was too detailed, it was not detailed enough. Again, this helps us plan future webinars so we can have the right people answering the right questions for you. All right, so we're kind of teetering on the edge of had the right level or was not detailed enough. So that was good. It wasn't too detailed. We didn't lose anybody. So that's good. And our last question is one that you can type your answer in. So if you're not sitting in front of a computer or something with a keyboard, you can always email us your answer to this question at ermstakeholder@cnl.ca. So we'd like to know what topic you'd be interested in attending a future webinar on. It can be related to something that you've heard today, or if you have another topic in mind, you can share your thoughts with us and we'll take that into consideration. And just as a reminder, while people are answering this question, you can still be typing your Q&A into the question and answer bar or button at the bottom of your Zoom bar. So Mitch, we can probably leave this poll open for a little bit, so we'll give people time to think if you want to start going through the Q&A. We'll do a little bit of double duty here.
Sure thing. Yeah, it looks like we've got a lot of questions, so let's get started. Okay, so the first question we got up is what kind of conditioning is planned for the legacy AECL used fuels to meet the Nuclear Waste Management Organization's waste acceptance criteria? Kyle, looks like you're coming on, so.
Yeah, that's a great question. And the short answer is that it depends. So as I mentioned, a significant portion of the ACL inventory is prototype CANDU fuel, which is very similar to standard CANDU fuel in that it's uranium oxide fuel, pellets clad in zirconium and arranged in bundles, similar in size to CANDU fuel. And for the most part, that prototype CANDU fuel, the conditioning may not be required to meet the WAC, and we're anticipating these might need to be inspected and potentially repackaged. But the research reactor fuel we have is quite diverse with many different designs and types. Most of the research reactor fuel is in the form of much longer assemblies, like 10-foot long versus a CANDU bundle, which is about 2 feet long. So at a minimum, they would need to be size reduced in order to interface with NWMO's handling and packaging systems. And then in some cases, we anticipate that the cladding for a research reactor fuel or the fuel material itself, or both, may be incompatible with the conditions in the DGR. So some of these may need to be stabilized to a form more similar to CANDU fuel and repackaged. That's why we're working to evaluate a range of conditioning technologies and evaluate their applicability to our various fuel types.
All right, thanks, Kyle.
No problem.
All right, yeah, we're getting lots of questions in here. So next question I have is and I think this is for you, Caitlin, for the CAS facility, what elements were prioritized for considered in determining the location of the facility?
Yeah, so this facility completed a site selection process through our management system manual procedures at site. And team members from across the organization are included in this process. And that includes our environmental protection team, our site planning and property management team, members from our health, safety, and security team members, operations, and also folks from more of our construction side. So groups met to discuss various site options. And during this process, it's really important as facilitators of the exercise to learn and understand the various criteria that are significant to each part of the organization. So some of the criteria that had the largest impact on the site selection were the utilization of disturbed lands, exploring the utilization of existing site infrastructure, looking at ensuring that we're improving efficiencies during operations when the facility will be turned over for actual operations, and then also ensuring that we're limiting our impact to existing operational facilities within each area that we're exploring. So the site that we selected, that was selected through this process, it's near the existing waste management areas. It had a very limited impact to greenfields. It improves our efficiencies during operations, which reduces our overall carbon impact or operational carbon impact. And then it also allows us to work well with existing operational facilities in the chosen location.
All right, thanks, Caitlin. Yeah, lots of questions. Okay, so next one. I think this is on the tritium facility. So Brennan, will the tritium that is removed from heavy water be converted to and stored as an elemental tritium gas, as is the case at the Darlington tritium removal facility? Could this tritium be used for weapons?
Okay, thanks, Mitch. Good question. So it's kind of a two-part question there. So I'll try and answer the first part, and then we'll move on to the second one. So will the tritium be removed from heavy water and be converted to and stored as an elemental tritium gas? So that is correct. The tritium is going to be removed, and it will be stored as a tritium hydride on a titanium plate. And then that is within an ITC. An ITC is a immobilized tritium container, and that is a suitable container that we use to store that. And that's also put into a tritium vault. The second part of the question is, could this tritium be used in nuclear weapons? And to respond to that, Canada has strict export controls and does not export this tritium material for weapons use. So hopefully that answers those questions.
All right, thanks, Brennan. All right, next question. I think we got Sean Gamley on the line because this one would be for him. Does CNL have a preference between a deep geological repository for fuel waste only versus a deep geologic repository that could accommodate both used fuel and intermediate level waste?
Thanks, Mitch. So for those that don't know me, Sean Gamley, I'm the manager of planning and waste strategy for CNL. Short answer is, at this time, CNL does not have a preference for a DGR for fuel waste only or an integrated one for used fuel and ILW. And I'm not sure who asked that question, but for those on the call, a bit of background for that is the NWMO in August of last year released a draft integrated strategy for radioactive waste, and they proposed a national single solution deep geological repository for ILW disposal. But they did not make a recommendation on whether or not that DGR should be a standalone facility for just ILW, or if it should be combined with the one that's been planned for about 20 years related to the DGR for used fuel that Mr. Shinui talked about previously. So in this process, CNL is a very active participant, but we are a participant for a process that NWMO is leading, and they're making recommendations to NRCan. So back to the original thing, we don't have a preference, but we are very actively supporting, gathering information and looking at the options for that, but it's something that will be sort of evolving over the coming years. So it is something that definitely we'll be paying attention to. And for those interested in learning more about that, would really encourage folks to check out the NWMO's website. It's radwasteplanning.ca. And on there, they've got the draft integrated strategy for radioactive waste. And that's sort of a national one that includes some CNL waste, but it's not a CNL document, but just context of what's going on in the nuclear industry. Hopefully that answered the question okay.
Thanks, Sean. Okay, I think we have one for Mark Chapman. Is there a disposal path for the molybdenum 99 medical isotope waste that remains on the Chalk River site?
Yeah, a great question, Mitch. Thank you. Just for a quick background, the cemented moly 99 byproduct or waste form we have on site is the result of 40 years of moly 99 production at Chalk River. The benefit to Canadians and society in general is over 1 billion medical treatments and diagnoses. So it was an amazing sort of plus for not just Canadian health, but global health as well. The cemented byproduct, we've got several treatment options that we've developed for it. They have different outcomes but they all look like they're viable for their different options. So we'll be proposing and running through those different treatment options, both with our stakeholders as well as our clients as well, and going through the different options, and then people can decide and weigh in which option best fits the values of what we're trying to achieve.
Thanks, Mark. Mark, do you mind introducing yourself? Because you got Rachel Chenette as your.
Do I? Well,
just so people aren't
that's a good name
confused.
too. It's I'm not Rachel Chenette. I am Mark Chapman, director of the Fuel Program Division here at CNL.
Thanks, Mark.
Thank you.
All right. Let's see what we got here. Okay, another one for Kyle. The facilities that are storing the fuel today, is there a design end date for them? And will Chalk River Laboratories have the capability to store all these fuels?
Good question. Yeah. So yeah, there's obviously a wide range of age classes for the facilities we're currently using to store used fuel. There's no end date in particular for when we need to move to another storage solution. We do continuously monitor the performance of those storage structures and report on that to the CNSC. Yeah, we continuously monitoring long-term planning to replace those. Do we have enough capacity now? We do for what we have now. It is likely though that we'd need modern storage facilities to store conditioned waste as it's conditioned, packaged for eventual disposal. I hope that answers that question.
Thanks, Kyle. Next question for Sean again. Will the CAS facility go through a CNSC licensing process?
Yeah, so Sean Gamble again, yeah, it will go through the process. So the CASC facility is a nuclear facility, and like any nuclear facility, there's a very robust sort of phased process that the CNSC expects all owners and operators to go through. So it is a process that has been started several years ago and is ongoing. It did include a public posting, a Section 82 posting on the Impact Assessment Agency's website. And there's a very wide variety of deliverables that support that licensing process to demonstrate that both the construction and future operation of this facility can be done safely. And with the licensing of any new facility, one thing to note here too is whenever we're thinking of building a new facility, we're thinking the life cycle. So we are looking at the future decommissioning of that facility and the future sort of management of any waste that comes from that facility. So that is all part of the licensing process, and the CNSC licensing process is a life cycle process. So I think that's an important thing to note whenever we're talking about any type of enabling facility. And sort of looking at that plan for whether it's 50 years of operations or 70 years of operations or 10 years of operations, looking at that whole thing. And that is all subject to the CNSC licensing process. And for those that are interested more, like CNSC has a good website that outlines that, and it sort of puts the expectations that CNL and any other owner operator has to follow.
Thanks, Sean. And I'll probably just add on to that, just so we clarify. There are different licensing activities related to the Chalk River site. So I know a lot of people are aware of kind of our big licensing activities, which right now out in the community, you'll see a lot about, obviously, the near surface disposal facility, which is going through an environmental assessment, as well as the nuclear power demonstration project that is going through an environmental assessment. Those are projects that are outside the current scope of the license at those sites, and that's they're undergoing an environmental assessment where a licensing decision is being made. The CAS facility is proposed as a facility that isn't introducing any new licensing requirements to the site. It's being built to improve an activity that's already happening at the site. It's not new. It's not proposing anything new that we're not already doing. It's just improving the conditions by which we would do it. So just to clarify the difference between what's out in the public and licensing and some of the nuances with how different things are licensed. So okay. All right. Do we have any more questions? Okay, we got, actually, speaking of near surface disposal facility, we have one sort of related, but is kind of in the scope of the enabling capabilities. So if the near surface disposal facility, basically, this is a question we've heard these before. If the near surface disposal facility is proposed right now, and as I mentioned, it's going through a licensing process, and let's this is obviously hypothetical. It's delayed or rejected by the regulator. What would be the impact for the management of low-level waste going into the future? Do we have currently enough storage, or will we have to build new storage into the future? So I'm not sure.
So I'll take that one, Mitch.
Okay, go ahead, Sean.
So we don't actually have anybody from the NSDF project on this call today. So again, I'll give a bit of an overview response to this. So at this time, we do have storage capacities for the planned waste that we're going to generate before NSDF is operational. And there is contingency because there is an element of the time phasing of different projects related to our cleanup missions at Chalk River and other offsites. But one of the key things that we've sort of communicated in the NSDF environmental impact statement is that continuing to build additional temporary storage systems at CRL is not consistent with modern waste management principles. And this is something that was part of the NSDF project for a while, in CNL sort of leading that transition from storage, which is by definition temporary, regardless of how long it is, to disposal, which is tended to be final and permanent. But it's also really reflected in the new radioactive waste policy for Canada. So for those that aren't familiar, at the end of March, Natural Resources Canada, the Minister of Natural Resources, announced the completion of the new policy for radioactive waste management and decommissioning. And in that, it really talks about the need to transition from storage frameworks to disposal frameworks. And that really is the element of minimizing the burden on future generations. And so at this time, CNL is really focused on that, not using sort of a rolling stewardship and building more storage facilities for low-level waste management, but moving to that disposal framework, which aligns to the modern best practices that we see, not just in Canada, with the radioactive waste policy, but on a global basis with other nations with a mature and well-established regulatory framework. So again, bottom line, short answer is that continuing to build temporary storage systems at CRL for low-level waste is not consistent with modern waste management practices.
Thanks, Sean. I know Rachel's typed into the chat here, but someone's hand is up, but in the audience. But we obviously don't have. We're not taking questions orally, so if you have a question, your hand's up. Please type it into the Q&A, and we'll get to it. Okay, I think we got one last question here. Does the full life cycle of a licensed facility include abandoning that facility? I think, Mark, are you able to answer that question for us?
Yes, I can. Does it say Mark now, or does it still say Rachel?
It's Mark now. You got
All right.
fixed.
All right. Thank you. Yeah, that's correct. So all new ERM ERM facilities life cycle plan includes the entire life cycle of that facility, right through to decommissioning of that facility once its mission is complete. And one of the big things about addressing in that format the full life cycle is that you're allowed, if you include the decommissioning aspects of it, you focus those back into the design aspects to improve the ability to decommission the facility at the end. So we've learned a lot over the last 7 years of operations, how to design facilities that are more conducive to being decommissioned at the end of life.
Thanks, Mark. All right, I'm not seeing any other questions, so I think we've gone through them. And again, though, if you do have stuff that comes to your mind after, please don't hesitate to send us an email at ERM stakeholder relations at cnl.ca. The email's in the start of the deck here, and probably was as part of the registration for this Zoom. Okay. All right. Well, with that, I think we'll wrap things up. I want to thank everyone for their time today. We really do appreciate you spending some time with us and learning a little bit about what we're doing. As I mentioned, this will go up on our YouTube page, so you can look at it later. And if additional questions occur, please don't hesitate to get back to us. We do these bi-monthly, so pay attention to CNL's social feeds and the local papers. We advertise these on a regular basis, bi-monthly, and let your friends, family know they're interested in different things to please come on in and participate. So with that, again, thanks everybody. Thank you to the staff that are on here with me, Kyle, Sean, Caitlin, Brennan, Mark. Appreciate you guys spending time with us and helping people understand what you're up to. So thanks everybody, and have a good day.